You might need your headphones.
I just turned it all the way down. There's my theory.
Hey, can you guys hear me okay? Am I too loud? I haven't set up Twitch before, so this is my first time. Yeah, how's that now? That should be much better. That way it's facing where I'll be pointing. My drink ready? I'm gonna wait a couple minutes just in case people haven't set up a Twitch before or they haven't had one, because I had to create one and it's new for a lot of people. While we're waiting for anyone else to show up, are there any specific questions anyone has that they want addressed beforehand? No. When you're as slow as I am and you have to go over it as many times to fully understand it, it gives people the false impression that you have obtained mastery, when in reality you've become very good at hitting yourself in the foot, so now you cannot do it occasionally. You know, I actually think that whole industry is like overrated. Like, I shampoo and condition my beard like I do the rest of my hair, and like brush it and comb it, and it just keeps growing. I mean, not too much you gotta do. I feel anyway. And beard oil, the thing that they won't tell you about beard oils is like they're good for like 4 or 5 hours, and then they start to smell bad. It's gross. Yeah, then you start smelling like rancid oil, like you smell it, and you're like, where's that smell coming from? Oh, yeah, it's coming from right underneath my face. Eucalyptus is one of the few scents that does not get musty like that. So, yeah. Mm, I think we'll probably be good. And if anyone else shows up later, I can just fill them in. I'm going to be solving this in Visual Studio. Visual Studio IDE. It's where I prefer to do the majority of my exercises. I know a couple of our assignments have gone over how to set it up. So I'm going to be creating a new console application. It's the one screen you guys can't see for some reason. Awesome. I'm kind of going to do this so you guys can follow along at the same pace. I'm going to get the file that the professor posted, Now, I know my professor posted an updated version of the file because there had been a typo in one position. So if you're in the same class as me, be sure you've gotten the most updated file. And we're just gonna take out all that stuff that's in there from the beginning of creating it, post his program in there. We can actually may uncommon as a Visual Studio requires. Okay. So you'll notice right away from his code, before we even review it, we've got some red squigglies, which are always the sign that something's not quite right. If you pull up the assignment details, let's see here. I have a copy. It says the assignment relates to the content from chapter 13, which in the book, chapter 13 is extremely helpful in completing all of these exercises. I didn't read it and attempted to complete all these exercises, and it caused me a lot of suffering. Only after reading it was I like, oh my gosh, I should have read the chapter in the first place. This all would have been super easy. But like, hindsight's 2020. And speaking of 2020, I need to get my glasses before I give myself a headache. Awesome. So the instructions indicate that we're supposed to download the supplied code, not to change anything in the supplied code. We're going to use the file names listed below, since your file will have the same components in the supplied code. Recall that in C++ there are no check on array index out of bounds. However, during program execution, an array index out of bounds can cause serious problems. Also in C++, the array index starts at 0. Design and implement the class myArray that solves the array index out of bounds problem and also allows the user to begin the array index starting at any integer, positive or negative. So immediately, if they were to start the array with a negative integer, that would be out of bounds because the array starts at 0. Can't be -1 spot in the array. Doesn't make sense. Not allowed. So the next section says that every object of type myArray is an array of type int. During execution, when accessing an array component, if the index is out of bounds, the program must terminate with an appropriate error message. Consider the following statements. And then the professor provides kind of an outline of what he expects to happen when he executes certain sections of the code. I can actually... We'll go there and take a quick peek. Just so we are all on the same page. So that's the text that he enters. And honestly, this is really confusing. It confused me the way it's laid out. I was like, what is it supposed to do? But like I said in the beginning, I have to go over things a lot of times to fully comprehend them. So this is a visual example of what he expects from the output. Kind of like he explained it up top. This is what it should look like when it works correctly. So we're going to write a program to test the class myArray. And then we're going to zip and submit it. Awesome. Back to the textbook. And I'm going to head back to Visual Studio. Now, in Visual Studio, one cool thing that we can do is we can just go over to the source files. We can right-click on one of our source files, and we can go to Class Wizard. You're in the coding wizard to learn how to use the Class Wizard. We choose our console application 3. Our class name will decide, oh, he actually stipulated needs to be my array, add class. Oops. And look, it even does your header file, your CPP file, and later as we get more advanced it'll do base class and whether or not it's going to be inline or not. Not going to be covered in the scope of this video. If I make further videos, we'll talk about it. We hit OK. We can just close that since it's already created them for us. We notice that right here we have a myArray CPP inside of our source files where it belongs, and above it in our header files folder we have our myArray.h, which is going to be our header file. Now before I get into actually like approaching how we would even take the steps to formulate the solution, there are a couple concepts I want to cover that are in the book. Let's see here. It's going to be in chapter 12, and if you open the copy of the book that I provided in the chat, you can pull open the table of contents on the left hand corner if you're using a browser to read it like I am. I switch over to that browser scene there. Okay. Right here on the left hand side, we're going to be going to chapter 12, pointers, classes, virtual functions, and abstract classes. So in the past two chapters we've talked, the previous chapter was 12, this chapter was 13. We talked about pointers and references. And the examples given were okay. Like in large integer, we used a pointer so that we could instantiate a new class every time, or a dynamic array every time we wanted to create a new array. What we would do, I've had the chat closed this whole time, so I don't know if anyone said anything. Let's see. Can you please for a second? Okay, zoom in a bit. Okay, on the textbook? Sure, here we go. That's probably good. And the Visual Studio. Okay, cool, cool, cool. I'll have to look into making that a little bit bigger. I think I can just... No, I can't. We'll figure that one out. If I have to, I'll open the code in a Word document to make it larger so that we can all see it all. Oh, the class wizard didn't show either. Good to know. I wonder if I can just turn it to capture my whole desktop. And these are the beginning troubles that we're going to work out together real fast. There you go. Do you guys, did that take effect immediately? No, don't say I sound like Roscop. I don't know. Okay. So from now on we should be able to see the class wizard. You just have to see all my messy taskbar. And if I look at my notes, you'll have to forgive me. I'm sorry. I have the memory of a goldfish. We covered references and we covered pointers. So for pointers, I'll pull up my notes since I guess you guys are going to see them anyway. Pointers and reference. A pointer is a variable that holds a memory address of another variable. A pointer needs to be dereferenced with the asterisk operator to access the memory locations it points to. If you're reading the textbook as you follow along here, you go to chapter 13, it's like page 865. Oof, a little too far. or 965. Somewhere in here, it's going to talk about pointers and overloading and references. But for the basic information, a reference is an alias to an already existing variable. A pointer has a place in memory that points to the data. So the key difference is that a reference must be initialized when it's declared. We use the AND symbol for declaring a reference as opposed to the asterisk when we declare a pointer. References cannot be null like pointers. We can declare a null pointer and then change it later. References can be used simply by name. Like if you declare int AND symbol as a reference to some other thing, a data type or an operator for a function overload, you can then just call int and that AND symbol and then name the variable you're going to be creating, and it's really easy to use. Pointer can be somewhat more complex because if you use it like we did in our previous assignment to create a dynamic array, you can assign values to positions in the array by using the pointer's variable name without the asterisk, and then you can change which position you're pointing to by using the variable name with the asterisk, which is example in the book. I'll find it so you guys can see it. I'll go to a specific page there. 838. I'll just show you in the program as we make it the differences between the two. I'll go back to the notes. So a pointer can be changed to point to any variable of the same type. So if we declare a pointer to int p, later we can change that pointer to different variables. A reference, once we initialize it, we cannot change that to refer to another variable object. That reference is set at compile time. So it's somewhat of a more permanent and somewhat more secure option, like using const when you're declaring an integer variable for a function argument. So we're going to get to actually writing the assignment. Put my stuff. Let's see if I can. Oh, I can even make Visual Studio bigger. Awesome. This is going to be great. So we're going to start with the class definition. If you remember, the professor said that the class has to be my array. Ooh. And I'm a hunt and find typer, so like, don't ever be worried about me making fun of someone not typing slowly, because I'm one of the slowest. So we have the basic form for our class, and if you'll remember from our previous lessons, when we make a class, the inheritance of its member variables is private by default. You'll see a lot of people when they declare their classes, when they're starting out, will put private up there. Like they're declaring that, hey, these are private, when in fact they're private already just by the nature of classes. So we're going to start with our variables. We're going to do int, and we're going to do, we need one for, let's go back and look at the assignment real fast, or the notes. I'll bring them back over here so we can see and kind of figure out how we're gonna do this. So actually an even better example would just be to pull up his code. Yeah, there we go. Okay. So right here in the beginning, at line 7, he's calling the class myArray, and he is going to call that instance list1. And he's going to give it one variable of integer type, and that variable is going to be a 5. So what this is going to do is it's going to call your default constructor of your class with the one supplied variable, and from the instructions that he provided, when he gives just a number to myArray, it should create an array of that size full of 0 value. So he's saying myArray list1 5. So he wants to create an array of 5 spots, all of 0. And that's going to be our default constructors. It will take the number and it's going to build an array of however many spaces out of that number. So for variables that we might need to accomplish that, we would need size. Let's move my notes back over. We would need to know where the array starts. We would need to know where the array ends. And those are the standard integer variables that we would need to know. We're going to keep a pointer in here because, like the dynamic array exercise, we're going to be creating an array, a dynamic array, out of the input that we're given as that variable there in the beginning. So we put that asterisk in there, and it's going to be called data. We'll give it a nice descriptive name. And there will be bonus points for anyone in the chat who can tell me why the asterisk is on that side of the declaration of the member variable and not attached to data. It's because it's creating a pointer to the data type, as opposed to if the asterisk were attached to data, it would be creating a pointer called data to an integer data type. There you go. Ducky's got it. So by putting it on the other side, we're creating a pointer of the data type int, and we're saying any data that is stored in int, or anything that is stored inside of the variable data, I'm going to be accessing with this pointer int. Yeah, I know, but I was so used to the last time I asked questions and it was radio silence, nobody answered. So I will wait next time and give you time to answer. I apologize. I wish I could get the stream. Does anyone know how to get the stream chat to stay on top of things? No, whatever. It's good enough. Awesome. So we've created that pointer to the data type int, and that's actually all we're going to need as far as variables to determine things we need to do with class, because really one of the hardest parts of this exercise is overthinking it. You read those super vague instructions with the pictures that show I'm printing all those numbers, and you're like, how am I going to accomplish this? In reality, all of that is done here inside of this file. He is doing the filling of the arrays, he's doing the printing, he's doing the user input. all your class needs to do is handle the construction of the arrays, which really simplifies the scope of the project and makes it simpler. So now that we're past the private members of our class, we're going to do the public ones. Oh, capital P, nope. There you go. And we're going to do the default constructor first. It's good practice, just like the first thing you do. And from what we saw in the professor's program, it's going to take a single value of integer type. So we're going to do an int. And we're going to just assign like an arbitrary name to this, like s. And that's been covered in previous chapters on building the constructors. And for this particular one, the way that we're going to approach building it, if you look at his code, that'll save you some time, is later on, after he's done playing around with the first two arrays, here on line 52, he's calling your class again. He's saying, now I want to create an array called list3. That list3 is going to start at position -2 and end at position 6. So he's inadvertently giving you the same variable that he gave you in a single digit in 2 digits. By giving you the beginning and the end of the array, you can intuitively figure out how large the array is, because if the array, you just shift all the numbers, the array starts at 0. To turn -2 into 0, you're just going to go up 2 spots. So your array is going to be 8 places, 8 spots, basically. I need a drink real fast. So if the second value that he's giving us is going to be a start and a stop, we need another constructor. But if you can only have one default constructor because the default. We're putting the asterisk on data, just make a regular int named data. It would create a pointer called data that points to an integer data type. So you could assign asterisk data equals a number, and as long as it was an integer, it would still point to that integer data. So by doing it the other way, you're essentially saying you're creating a data type pointer to the data that's being stored in data, referencing the other way around. It can be confusing. When you do it a couple times, it becomes a little more clear. Pick me students in the chat. They're not like other students. They're the best students. So we're going to make another constructor. Since we can't have another default constructor, it's going to be an overload. We covered overloads in this chapter, I believe, in number 13. So we saw the types of values it was going to take was going to be 2 integers. So we're going to do an int. We're going to do 2 letters. We're going to do a lowercase m for the minimum for the start. And you don't have to do the same thing. This is just how my brain works, and it's highly dysfunctional. So if you don't find it easy to copy me, that's cool too. And the other one is going to be int capital M for maximum. That keeps it organized for me. So now we have the overload constructor. The other and final step, actually, because there are not a whole lot of steps involved here, is we're going to need a way to determine if an insertion point, a place that we want to put values, is in bounds of the array that we've created. Now, the bounds of an array, like we said earlier, start at 0 and would go to the end of however large our array is. It's not a vector, so it can't expand dynamically. It can only be as big as it is, or we can recreate it and make it larger. So in our instance, we're going to need to design something that checks whether or not the value being inserted is at an index position below the start position or above the end position. If it is, we can go ahead and insert the value. If it isn't, we need to return an error message that's handling the problem in the program. And I'll show you what happens if we don't include an error message here when we code some more of it. So we're going to use a reference, which is, like we said earlier, similar but very different to a pointer. So it needs to be a reference to an integer. And like for the asterisk, there's differences depending on where you put it. For this, we're going to be writing an overload of the operator function. Those are covered here in the textbook under function overloading. That's page 959. Let's see. This is a good example. Okay. This is clock type. This is an example on page 937 of the book that features operator overloading of several different operators such as the insertion, the extraction, the equals, the increment, the decrement. So they have several of these overloads already defined here. I'll make it a little bit bigger because it's an insane color. I wish I could change it for you. I'm sorry. So they're basically saying, like right here, they're declaring, you have to say, hey, I'm writing something for an operator, and then it's followed directly by the operator, and then it's followed by the type of data this operator is going to apply to. So their operator equals here is a comparison operator. They're basically writing a function to overload the comparison operator to allow it to compare two different clock types. Oh, beige and green? Are you a troll? It's terrible. No, I'm just joking. Everyone has their own preference. At a time I like a light IDE, but that's only if it's sunny out and I don't value my vision. Otherwise, it's got to be black. But anyway, back to the overloaded operator. What they're doing is the comparison operator would not normally operate on data types of clock type because it's not in the standard definition of data types that the comparison operator worked on. It's not going to be able to intuitively look at both of those things and be like, yeah, that date, that's the same as that other date, for sure. Because unfortunately, computers, while they're staggeringly fast and able to do complex things, are not super intuitive yet. And that still leaves it up to us to make the majority of the mistakes. So, with that information about the operator, we're going to be overloading the operator that you see at the end of array. So the values of the index will appear inside this type of bracket. And if you remember, we put the type of data it should expect inside of the brackets here. We're going to do a const integer, and that's so that that reference cannot be changed later. The reason you would declare a function like this, so if you write a class definition and it's public out there with your program and someone decompiles it, or it's open source and someone wants to use your header file or implementation, if the variable is not set to a const int and then the type of it, it could potentially be changed at runtime or later. And that could introduce either stability problems, security problems, or both, because someone could introduce stability problems to cause you security problems. So generally, when you're doing things like printing the value of one member of your class, you want it to print a constant, because if you use that print function anywhere else in your program, like determining equal equal, or determining if a value is a password or not, and someone's able to get in there before that and be like, no, that int actually is just an asterisk, so any asterisk is valid. Now they can just log in with an asterisk, but that's a more advanced concept. I just wanted to explain why I was particularly doing it here. And this is going to represent the index position that we're trying to insert our value at. So it's going to be, I'm not even going to bother trying to explain until like I have the function to flip-flop back and forth to show you. But the reason these have the green squigglies under them, it'll even tell us here. I don't know if you could see that on the stream. No, it doesn't make it any bigger. It says that we haven't made a definition for it, that it's only a template. So we can go to our myArray CPP, which is our implementation file, and we can start coding the functions that we declared in our class, because earlier those were just declarations. We didn't tell it how it was going to accomplish it. So we're going to start with our includes, which I'm pretty sure I forgot on the last one, but I can go back and add them. So the good old IO stream, you can't really do anything without it. So we're going to include our header file. And if you remember, when we include our header files, we put them inside of the parentheses instead of the arrow quotes. I don't like to see a bunch of empty lines down there, so I put some empty space in there. It freaks me out. We don't need namespace or any other really complex functions. We're not going to be doing a whole lot other than basic comparisons and creating things. So we're going to declare the definition, or start defining it. If you remember, our class is myArray, and if you remember from our earlier lessons, these are called the scope resolution parameters. There's two dots in a row. Is it semicolons, or are they full colons? I was terrible at English, so I don't know. And remember, we declared that that basic constructor, the default constructor, is going to work on an integer s. And in a default constructor, we want to start just, if they don't supply a value, it should be 0. So we're going to do size equals s. And then start is where we do that 0 initialization. And then we're going to do our end initialization. And we're not going to just put a 0 there, because that wouldn't make logical sense. We don't want it to end at 0, and no one's going to be setting 0 or set the end as an argument for this function. So really what we would want to do is make it 1 less than the start. So we'll take it, or 1 less than the size, because with arrays starting at 0, if they want the size of the array to be 5, if you try and go until the array says 5, you're going to end up with 6 positions. So the end is going to be that s value minus 1. You could be, I guess it's better practice if you wanted to create another variable within the function to store that value of the minus 1, but I'm just going to throw that minus 1 in there for simplicity. So we have the size, start, and end We have one variable left for our default constructor, which is going to be that pointer to the data. Oh, they got all twisted around. Where are they at? Okay, there we go. And that data, like we did for the large integers, is actually going to be a dynamic array. And we set it as an integer. And we would want the size to be the size. So we're just going to throw size in there. So what we've done is, if they were to call my array now, before we add anything else to it, it would just create an array of size, which it would get from S, and it would have no values in it. It would just have slots for values. They wouldn't even be zeros. So that means our next step is that we just need to make a way to put zeros into each one of those values in the array that we just created. There are several convoluted or complicated ways that I have conceived to do this in the past, which are completely and utterly wrong, and I'm sure you've created some ways to insert or take data out of a list, but I'm going to show you the way that I ended up with at the end of this exercise that was both short, elegant, and functional, in hopes that when I explain it, you can take out of it. And the data we're assigning to be this new array is an integer pointer. I'm trying to think of the best way to answer this question. So in larger integer, we used a pointer to dynamically create a new array. Like we declared the int data earlier, and now we're saying data equals, etc. Yes. So by pointing that pointer to it at the int, and we're creating it in here as new int size as an array, it's creating a new array of data which we can access using that, basically that pointer, if that makes sense. The pointers and references section in chapter 12 at the beginning is a very good place to go for reference after this video if some of the things that I've explained don't quite make a lot of sense, and they have a lot of examples. So that I'm a visual learner, that's really helped me out. Yes, the name of the pointer is called data. That is correct. Okay, so our data, we create the new array of size. Now, we want to fill the array with zeros. And one way to do that is we're going to go int I equals not 0, because we already have a 0 declared. We always want it to equal the start. It should always equal the start of the array. So int I equals the start of the array. We want it to stop when I is less than or equal to the end of the array, right? That's pretty simple. And finally, every time the loop runs, I want I to increment by 1. My brackets like this are purely a stylistic choice. It helps me keep track of my fors in different levels, and when your program gets really long, it kind of helps to be in the habit of doing it. Don't feel obligated to do it, because you do not specifically need those after a for it to function correctly. It's just for me to keep track of what the content of that for is. So we're inside of our loop now. So int I equals start, which is 0, and we're going to go off the assumption not I equals 0 and while I less than size. So we have assigned end and start two integer values already. So while we've typed start, the computer just sees 0 and 1, or S in this instance. So what it's going to do, if on this, let's go with the professor's program here. The first one, my array list 1 using, or list 1 5 using our default constructor as we have it right now, with a 5 here, sets size equal to 5. So start is 0, end is 5 minus 1, so end is 4. So int I equals 0, and until I is less than or equal to end I++. We're kind of going from the bottom up. Because we have to fill the array at 0. I understand the confusion, yeah. Okay, now I'm going to type something, and then I will tell you specifically and show you a page in the book that will explain it. If anyone knows what that means immediately, kudos to you. I don't know why you're here in this video watching it with me. It took me a long time to wrap my brain around that. I'll give you a second this time to answer. Yeah, but specifically, what does it do? Cheeky. I just gotta find it real fast. Scrolling through the desert. If anyone can think of any specific questions while I'm looking for this, go right ahead. I'll look at them in just a moment. It's a really good example. Awesome. Okay, cool. Here we go. So, this statement, int pointer p, declares p to be a pointer variable of type int. The statement p equals new int, like we're doing now, creates a dynamic array. They're just doing it slightly differently. They've had the asterisk on the other side. So this allocates 10 contiguous memory locations, each of type int, and stores the address of the first memory location into p. So they say they have a evaluation here that says pointer p, so they're addressing the pointer directly, equals 25. And then the following page here stores 25 into the first memory location, and then the statement p++, which is an increment, and then pointer p equals 35. That increment operator on p without the dereference from the pointer is incrementing your position within the array that you have created, the dynamic array. So in essence, if you'll remember, we set earlier p equals 25, and then we did p increment, and then we set p equals 35. But if we were to print all of the members of the array of p, it would have two members. 0 would be 25, and because we incremented to 1, p at 1 increment would be 35. So we can use this dereferencing and assignment of pointer to both assign the location in the index and to move through the index, which I will explain here. So instead of just saying dereference the data pointer, we want to dereference it at a specific index, which is the I for our I loop here. So it starts out at 0. So at dereference data operator plus 0 is data index position 0. We've just set data index position 0 to 0. Now our loop repeats. I is now equal to 1. Data at index location 1 is now set to 0. Our loop increments. I becomes 3, and so on and so on and so on, until it hits the end, which, if you recall, is our size, or s minus 1. So it will stop at 4, which will give us 0, 1, 2, 3, 4. 5 positions for data, which is exactly what he wanted to happen when he called it with just the 5. So in essence, we have completed the default constructor. Our overload constructor is going to look very similar to this, but it's going to be designed to handle 2 integers. Good old copy and paste. We set those as minimum and maximum. Keep the chat open. Since data is the pointer pointing to a memory location, dereferencing is making it talk about the contents instead of the location. Yes. So you're dereferencing it at that location. So you're basically saying data at I now equals 0. Okay, we have our secondary function here. We've got a red squiggly, because obviously we have it now set to take 2 integers. But we don't really need to change it because we need the size still, the size of the array, and he is giving us the size of the array in a roundabout way. He's just giving it to us. He gives us the maximum, and we can just subtract the minimum from the maximum. And that's the size now. It will start at the minimum, and it will end at the maximum minus 1. That's pretty simple. Nothing too crazy. But our loop, will our loop work the same? Yes. Because the magic of reference and pointers, it still essentially does the same thing regardless of the type of data you're putting into it. It just wants to create an array. It just has to do a little bit of extra work now to figure out how big that array is. So we did some math in year and size, and on end stayed the same. But that's it. Our overloaded constructor is done. If you recall from the description, our thing needed to make normal arrays, build arrays from target addresses he gave us, and now it needs to determine whether or not an array index position is within bounds, and if it's not, it needs to report an error. So we defined, or we declared a function in here, an overload function. We're going to go ahead and write a definition for it. So the only thing that's different about copying it into here is, like writing a definition for a class member function, you do have to put the my array in here. And it is not the same as a member function definition. You have to put spaces between the scope resolution. Our red squigglies have gone away. We've corrected the format of this. So I outlined what specifically it needed to do, but we can put those actually into English. If the index is greater than or equal to start, which is the start of our array, and index is less than or equal to the end of our array, we can do some stuff. That means it's within bounds. What we wanted to do when the data was in bounds was allow it. Otherwise, we need to throw the error. So if we're just going to allow the data, we're going to use that reference that we declared earlier, the integer, because the data that we're checking is the index. So that integer reference is, we're now applying it to a variable. We're going to create a variable inside of this function called lm. That is a variable you can do some research on your own if you would like. It can reference elements inside of a function or class, but it's not a reserved word, so you can use it for other things. But you will see that people use lm to try and, for best coding practices, use it to reference the thing that they're talking about in here. So I'm saying the element, which would be in reference to this integer, now equals, and we needed to put it into the index, and if you recall how we did that, we dereference the data, plus, we're not going to do I because we don't have a loop. We would want to just put it in at the index if it's allowed. And then it should just return the element. Oop. There we go. I know you expect one. Oh, see, my stylistic choice messed me up. Even, it goes to show you, even I make mistakes when it sounds like this is super advanced stuff and it's going to be super hard and you feel like you're not going to understand it. Know that I always misspell super simple words, all sorts of crazy stuff. Like, the only thing that will make this stuff stick reliably is practice. Yes, I am recording this, and I will be editing it and posting it in the Discord for the other people. Okay, cool. No new stuff. Awesome. Okay. So now our function looks correctly, and that's actually supposed to be a close brackets. So there we go. That looks correct. So we now have a function that, if the data is correct, it allows us to insert it. This checks the position of the array. And it does it, to understand why you need this, you kind of have to look at the way that he is doing these tests. So we scroll down to 54. Oh, he rearranged it a teeny bit. He did, he changed it. Interesting. This is not how it originally looked when I did it. There used to be a section that he tried to insert some values at a negative position, and it would crash your program if you tried to run it without that error message, but it doesn't look like that's in here, so I'm going to just try and run it without that error message to see if it still does it. That looks, I don't know if, let's see if you guys can see that or not. So we're going to enter 5 integers. He entered 9, 8, 7, 6, 5. Sorry about the shaking screen, guys. I've never used magnifier before. So without those insertion tests that he had in the last one, the program as I have it right now works. It should not work. Get out of here. It should not work. It should print an out of range error, but it looks like he had to fix it up due to the typo. I'll show you how to put the error message in there because he will count you off for the grade for it. But if you look at it in comparison to the results that the professor wanted, this is, let's see here. There's the results from the professor, and here is the results from us running the program. Seven, 0, 54, 0, 15, 0, 8, 0. That's as right as I could hope to make it. So I press any key, finishes our program for debugging. The adding the error catching message is almost just extra at this point because we've already defined what it's going to do if it's right. So we just need to go one more down and put an else in there, and it's gonna...
Hey, I think you lost connection.
Am I back now? Huh. Oh, sorry about that, guys. Lost you for a second. I think it's probably I was changing windows too fast. Awesome. There you go. So our cout operator is going to be going to say error array index out of bounds. I'm actually like using the end line. And that's essentially it. That's all the error checking you need. If you don't define at least something to happen when an error happens like that, it will crash the program. It'll be an unhandled exception. You'll get an error code and your program will just close. By putting at least an arbitrary output, like the cout error index array out of bounds, it gives the program something to do in the event that that thing happens. And when it happens, it does it, and then it just goes about its merry way, because it's assured that I was programmed to do something about this particular circumstance. It happened, I did it, good. later, why we covered memory allocation previously is if you had a program that did this long term and it was allocating memory to creating all of these arrays, and you were sloppy about creating it and you did not create a function to delete that memory, over time that memory would build up and take up all the memory inside of your computer, and then you would get a page overflow or buffer overflow, and your whole computer would crash. If you're lucky, your computer would crash and it would just boot back up like nothing had happened. But otherwise, you could lose a lot of data if you're writing to a database. You corrupt your system files. So you just want to try and capture every exception, which is what we're going to be moving on to in the next lessons. But that's it as far as actually how to create it. As you saw on the screen, it ran. Are there any specific questions? Awesome. Well, good luck, guys, and good night.